Okay, so this morning we have a 2011 Chevrolet Aveo, and it's got a couple of issues. Customers complaining that an engine is overheating. He had to drive it here with the heater on high, and that managed to keep the temperature down. And as well as got a power steering issue. I think he said a power steering leak. I can see there's coolant blowing out of the overflow bottle. So we're just going to scan it and see what kind of codes it's generated. This is a code G engine, and it doesn't come up in the scan tool, but we'll have a look at what codes it's generated, because I see the check engine light is on. So here are the codes generated by a network scan. We've got a P00B7, coolant flow insufficient, a P0128, coolant temperature below thermostat regulating temperature, and a P0599, engine coolant thermostat heater control circuit high voltage. We'll have a look and see if there's any freeze frame data. So the freeze frame data is typically stored in generic functions, and we've got this thermostat heater control circuit problem. Wonder if it shows me the temperature of the engine at the time. Coolant temperature 77 degrees Fahrenheit, which is definitely not overheating. Number of warm-ups since the DTC is cleared, 202. So that's not much help. Coolant temperature was 77. Intake air was 87. Well, we're going to have a look at a couple of things to see what generically causes this problem. The cooling system appears to be full, but I'm going to double check the rad if possible. So the cooling system is full. If we go under failure records, GM's failure records, we're going to have a look at this data list to see if there's anything more in there, if it's different than, or this freeze frame. Or actually, it's a failure record. Concerned about the temperature. Engine runtime 15 seconds. Ambient air temperature 87. Where's coolant time? Oh, there it is, 77. So that's the same as the freeze frame. Let's check this insufficient flow code. Because GM does save more than one freeze frame. They call them failure records. Coolant temperature 246. That's definitely overheating. How long had it been running? So this DTC P0599 deals with an electrically heated thermostat, so chances are it has a problem with the thermostat, and that could concur or cause the overheating condition. So we're going to have a look at where the thermostat lives on this thing, but it seems to be fairly common cause this problem. So here it says the engine controls the module, controls the pulse width modulated thermostat. The thermostat controls coolant flow and regulates engine temperature. Whatever happened to just using a wax pellet? That seemed to be fairly reliable. Anyways, ignition voltage is supplied directly to the thermostat. The ECM controls the thermostat by grounding the control circuit with a solid state driver. The driver is equipped with a feedback circuit that is a pull-up to voltage. The ECM can determine if the control circuit is open, shorted to ground, or shorted to a voltage by monitoring the feedback voltage. So let's have a look at the schematic here. It looks like the should be this one, I think. Cooling fan, low cooling fan. Why do you give me the cooling fan circuit when I've got a thermostat? So it appears I picked the wrong one. So the thermostat has an orange-black wire which is fed power from this fuse. Where is this fuse? Underhood fuse panel. So we could check that, or check for power at this coolant thermostat, and it's ground side controlled here. So we're looking for an orange-black wire and a brown wire at the thermostat. So this is fairly convenient to get to. There's the connector to the thermostat, and if I pull this pin out here, you'll see there's an orange-black wire and a brown, looks like a brown wire, might have a trace on it. So I'm back pinning this orange-black wire, sliding it up to the pin, and with a test light to ground. Oh, I guess I missed it. Try this again. There we go. Hang on. So there's definitely power here. Now there could be an open in the control circuit, but chances are the thermostat electric heating element is open. So rather than check the control circuit back to the computer wherever it lives, we're just going to test the resistance of that thermostat heater. So I unplugged that thermostat, and I see that there's a connector on it similar to an injector connector. So put a Noid light on it, and with the key on, it's flashing that light, or at least it was. Now it's stopped. So obviously the circuit is good. I'm just going to check continuity of that heater because it's convenient to get to. So I connected 2 test leads across the thermostat connector, and it reads 0.58 ohms, which might be low, but it's definitely not open like I expected it. So we better look and see what the spec is for this thing. So here's the troublemaker chart from General Motors. Ignition off, disconnect the harness connector at the engine coolant thermostat heater, key on, verify a test lights on that wire on terminal 2. If it doesn't, check that circuit. Command the engine coolant thermostat heater to 10% with a scan tool. Test for 2.5 to 3.5 volts between the control circuit terminal 1 and ground. I don't get that. That doesn't make sense. Are you backpinning it? If greater than a specified range, test the control circuit for a short to voltage. Well, a digital multimeter is just going to average it either way. Why they don't measure the resistance of the heater. Okay, so I'm going to command the coolant thermostat heater circuit on with the scan tool, and it's 0% right now, so I'm going to command it on to 10%. And as you can see, it's flashing the Noid light here, so I'm sure the circuit is fine. We're going to go ahead and order a thermostat. We're going to qualify the resistance of the thermostat when we get the new one too. I don't understand how come they got to make things so complicated. So there is the part number for the thermostat assembly. Here it is here. You can see it comes with the heating element inside there and the housing. Looks like there's 4 bolts that hold it on. Looks like it's fairly convenient to replace. But we're going to put an ohmmeter across this and compare it to the original one. Remember, the service information didn't mention anything about checking continuity of that, but we're going to check it. So with the ohmmeter connected across the new part, I'm on kiloohms. It shows 15 ohms resistance, sorry for the glare, 15.23, and I'm pretty sure the other one was less than 1, but we're going to check it again. So there we are connected across the original one, and it's definitely shorted 0.67. So why wouldn't they just have a resistance test to qualify this thing? It's so easy to do rather than, oh well, that's why they call them troublemaker charts. So there are 4 fasteners, and you need an E10 socket to remove them. Drain the cooling system, or just put a large catch pan, which I've done underneath there. And remove the housing assembly with the 4 bolts. There's the old one. So we'll go ahead and put a new one on. So I've cleared the codes out of this thing, installed the thermostat, and refilled the cooling system. I have yet to start it, so I want to watch the radiator coolant temperature sensor, the engine coolant temperature, desired coolant, and thermostat housing command. So we're going to go ahead and start it now. So we're going to let it run for a while and see what temperature the thermostat opens at. We should be able to tell. It's interesting, the desired coolant temperature is 222 Fahrenheit. It's already starting to rise, 86 Fahrenheit. So we'll pick up when it's nearer operating temperature. So after running for about just over 5 minutes, I've got a run time here, we're at 127 degrees Fahrenheit. I looked at that old thermostat and it's marked 105 degrees. Now I would imagine that's 105 Celsius, which would be about 220 Fahrenheit. I'll double check that. But we'll let it run and see what temperature the thermostat opens at. So we're up to 217 Fahrenheit. I don't think the thermostat is open, just went to 219 after 13 minutes of running. And it isn't trying to command that electric heater on according to this data parameter. Now there could still be a slight airlock in the system because the thermostat hasn't opened yet, but we'll see what happens. 221 now. So the thermostat looks to be like it opened at 224 Fahrenheit. I'll have to check that 105 Celsius, but I think that's around the temperature. It isn't commanding this heater on, so that's just relying on the thermostat. And we got to run it through the warm-up cycle to get a airlock out of the system. The radiator temperature has climbed a little bit, not much. So it's just barely starting to open. So I can feel the upper radiator hose is starting to warm up. So it is obviously opening, but not a lot of coolant has circulated through that radiator yet because the radiator temperature hasn't changed yet, still at 78 Fahrenheit. So this thing has been running for almost half an hour now and the coolant temperature is at 224. Radiator temperature is only 82 according to this. I'm going to shoot it with a non-contact thermometer, infrared thermometer, and see if that's realistic. Got it up on the hoist right now. So up in the air we're having a look here and I see somebody must have put a jack on this and jacked up here on the lower part of the rad support and pushed it up significantly. I don't think that got hit like that. There's a mark here, looks like a jack mark, but whatever. It's not affecting the rad. I'm shooting the bottom of the rad with the non-contact thermometer and it shows about 145 Fahrenheit, so possibly that temp sensor for the rad is skewed. I'm not sure where it is because it's showing right now 86 Fahrenheit. I'm going to see if I can see exactly where that temp sensor is. The other problem that he's here for is a power steering leak. So I see the problem. Let's get the light up here. There. So it just started blowing off coolant from somewhere. I'm not sure where. Oh, the housing is leaking. Isn't that special? Let's shut it off. Well, that plastic thermostat housing is cracked, or the housing behind the thermostat, right in here. There was coolant all over everything before, so it could have been cracked before and I never noticed it. But I'm not completely convinced that the electric cooling fans didn't come on, but then again the radiator temperature wasn't hot enough. Well, it's going to need that plastic housing. That's probably a dealer item. So having a look at this now that it's semi-cooled off, and you can actually see the crack in the housing right there. And it goes down the back now. That had to have been cracked before, but I just talked that off the phone with the dealer. They're going to send me an exploded diagram. It's a good chance that that housing comes with this thermostat assembly now that I've already replaced it, but that thermostat assembly was definitely pooched. Anyways, it's going to need that plastic housing that has 2 heater hoses attached to it and a temp sensor and some other coolant bypass line on it. Oh joy. So I got the dealership to send me a picture, and this is what it is. Yes, it is serviced as a complete assembly with the thermostat that I just bought. and it's $450 from the dealer. So I thought I'd Google it, and I see a number of them for sale, including Amazon.ca. There it is on Amazon. Chevy Sonic, Trax, Tracker, Cruise, Aveo, Aveo 5, Pontiac G3, 1.6. By part number. That looks correct. I better double check that part number, but that sure looks right. Replace. Part number they gave me was 25199879826. 251999826. I don't see that here. 228, but that's the one that comes up. I see Dorman has a part number too for this thing by the looks of it. I'm going to get the part number from Dorman and see if I can source that. There's another one. That's wrong though. Yeah, these are just typical numbers. So here's a replacement thermostat housing assembly with the thermostat from Dorman, part number 902-033. Retails for $170, and the thermostat alone was $150. So that's a no-brainer. They actually have it in stock, so I've got it ordered and coming out. So hopefully we can return that thermostat assembly, even though I've put it on already. I think I can convince them to return it. But it's a lot more work to change the whole entire housing, because there's a nipple on this side, two heater hoses, and a temp sensor in it as well. But I'm still curious as to why that radiator cooling fan didn't kick in, although I don't know if it was being commanded on. I'm going to see if it runs. So here's the bidirectional control of the radiator cooling fan. I'm turning it on. I can hear the relay click on, but the cooling fan is not running. So, and it's not because the radiator support is bent. We're going to have to see if we got power to that. There is another radiator cooling fan relay. I wonder if that one makes a difference. So radiator cooling fan relay 2 commands the cooling fan on, and it runs. It appears on high. So I wonder if there's two speeds to this thing, and one speed has failed. So there's a dropping resistor or something. I'm going to have to look at the schematic. So I was right. The cooling fan motor only has two wires on it. One is grounded all the time, and the other one is fed power from this splice. And there is a cooling fan dropping resistor. The low-speed cooling fan runs through a resistor, and the high-speed cooling fan runs direct. Now there is a fuse in here, so we should check that fuse. I could hear the relay turning on, but let's test that fuse first, and then we'll check this dropping resistor. So in the schematic it called it fuse 24, but on here it doesn't give a number. It just gives low-speed fan low, which is that fuse right there. Key on. I got power on both sides of that fuse, and this is fan high, and this is the fan low relay, fan high relay, fan low relay. So we'll find that dropping resistor. Well, somebody got paid to use up a bunch of dropping resistors from the 70s. So there's the dropping resistor attached to the left front frame rail, just in front of and below the battery. I don't know if you're going to be able to see it in this diagram or in this camera angle, but that's right out of circa 70. You know, spade terminals, screws on them. Well, we'll check to see if there's power being sent to that when we command the relay on. So I've got the scan tool commanding the relay on, and I've got a long test probe that I can put down here onto that terminal, and it's insulated so that it doesn't. Let me get the light in here. Oh, I missed it. There we go. You can see there's power on that side of the resistor, but if I go over to the other side of the resistor, no power. So that dropping resistor has failed. It's funny they didn't work in the 70s. Why would they expect them to work again in the 2000s? So I'll see about that dropping resistor. I'm sure that that's the reason why the fan doesn't run on low, although it should run on high and prevent it from overheating. But we have a coolant leak, failed thermostat, failed dropping resistor, and the power steering rack that needs to be replaced. Oh joy. Well, according to the parts counter guys, parts information website, I can't find it on their website, but I did find a GM part number, 948-12213. So I'm going to go back to these guys and try and see if we can stock that. 948-12213. Resistor. They call it a daytime running light resistor. Now let's see where it's stocked. No parts found. Well, I'll have to make a call tomorrow morning and see if the dealer has it. It's obviously available. 32 bucks. Oh well. So, no aftermarket steering gear available from the local suppliers here. Nothing from Napa, nothing from APC. Obviously it's available somewhere.